What is the length OA? So spring is elongated or compressed? It is being elongated. So spring force will act here. The weight mg will act. It is released from rest here, this ring. Now let's go for the forces acting. Spring force kx1, the weight of the ring mg. Under action of these two, of course, normal reaction will act here. How the normal reaction should act? Normal reaction should act in this direction. Already we have discussed some ideas, because the spring is trying to pull the ring. No, okay, this part of the ring will be in contact, not this part. This part of the ring will be in contact with the pole. The pole will exert force on the ring in this direction. Under action of these forces, now it is going to slide down. So when the spring becomes horizontal, here I can show clearly. Look at this one now. What is the state of spring? Will it be elongated or compressed? What is the natural length of the spring you look at? Natural length of spring is 4 meters. Then what is the length OB? 6 meters. So again, it's here also it's elongated. I'll write here. L naught is natural length of spring. So what is the state of spring? Spring will be elongated. So it will have the velocity v here. No. Okay, we are very good in kinematics, no? So what shall we do? We will take off our kinematics here. Look at the forces acting. Spring force acting, is it a constant or variable? Its magnitude will change, and also the angle between spring force and the pole will change, no? So what is the forces that are acting on the weight mg, and also component of spring force? The theta will change, and also the magnitude, both f and theta will change. So writing equation and solving, no, very difficult. You try it, very difficult, because on the system now a force F is acting whose magnitude varies and also direction changes. Then very difficult to integrate. We don't have mathematics. Then how to solve this problem? That's what we are trying to do now. So if you are trying to write expression called this theta, then what is the acceleration of the ring should be equal to mg plus kx1 cos theta. Theta variable, this x also variable. We can't write and integrate anything here. It's not possible. Can we apply conservation of mechanical energy? Because what are the only forces doing work? The weight and spring force. What about normal contact force? It will act perpendicular to displacement. Work done by normal contact force 0. Weight and spring force are also only forces acting, are doing work. So therefore, I can apply conservation of mechanical energy. For your understanding. These are the forces that are acting here. Kx. This is theta. So what is the acceleration? Just a student, if we can think like this, it's a what is x and theta? Both are variable. Other side, if you want, you can write v dv by dx. Look at the problem what we face now. We can't integrate here, not possible. Theta we don't know. X and theta, v, x and theta are variable. Nothing wrong in equation, but we don't get answer. So how to calculate the speed? So I'll go for conservation of mechanical energy. Work done by normal contact force 0. And then UA plus K equal to UB plus KB. Elastic potential energy kx1 square by 2. Gravitational potential, we don't know this H. Let's see how we can bring. Plus it is released from rest. No. So what is the elastic potential here? kx2 square by the gravitational potential is 0. Kinetic energy is what we needed. Do we know x1, x2? What is x1? x1 should be equal to OA minus L naught. 10 minus 4, 6. Do we know x2? x2 is how much? OB minus L naught. 6 minus 4, 2 meter. Both are elongation only. We don't know h. From Pythagoras theorem, OA square equal to OB square plus BA square. OA, it is given 10 square. OB 6 square. So BA, this is nothing but h. Substitute all this, you'll get the velocity of the ring. Now think it, if you don't know this, what you do? We can't solve. So this is one advantage with the energy aspect. We can minimize mathematics here. Just do remember, work energy theorem and conservation of making, what they do, they will try to minimize the energy, they'll try to minimize the mathematics involved. The rigorous maths can be minimized with the help of this one. Moreover, the energy aspect is something very important now, because we can learn the system, who is actually doing work, who is not doing work. Then kinematics and laws of motion approach, the work power energy chapter, we are going to analyze the system in depth. Okay, these are the types of numericals what you are going to work out. If non-conservative force also doing work, then what you should do? You should shift to the work energy theorem. If only conservative forces doing work, take help of conservation of mechanical energy. But work energy theorem is applicable in all the cases. So if you find this conservation a little bit difficult, go to work energy theorem. It's a universal. Whatever the force you can manage. Make observation. We'll wind up the class. This is like some fundamental for us in the total physics. No, all these are like a fundamental, not like numericals.